Okay, hey Fraser.
Hi Fraser.
No, you missed your window. Okay, number 7. Shh. All right, number 7 had this crazy graph, huh? So this is what, 6.2? Number 7. All right. So it says an 85 kilogram passenger. So our mass is 85 kilograms. He is made to move along a circular path with a radius of 3.5 meters in uniform circular motion. I think I didn't stress this in the notes. So when it says uniform circular motion, the assumption there is that the radius and velocity and frequency are all constant. Okay, that's what uniform circular motion means. Okay. A says, graph A is a plot of the required magnitude F of the net centripetal force for a range of possible values of the passenger's speed. What is the plot slope? Oh my God, holy cow, look at this thing. All right, so let's see. Here we go. Force versus velocity. The graph looks like this kind of ish. It's not, I don't think it's supposed to be a, a x squared function. So it wants to know the slope when the velocity is 8.3 meters a second. Everybody agree that that's the deal? Okay, so you guys are going to be mad.
Not really.
Nope? Okay. All right. So the frustrating thing is that the graph doesn't have any numbers on it at all, right? Okay? So what'd you say?
I just did the definition of the derivative.
Just did the definition of the derivative? Okay, all right, so thoughts about where to get started? You guys help me out. Sure, what do you got, Evan?
Well, you know that the slope of velocity time graph has acceleration, but it's not velocity time graph.
Okay, so you're telling me that dv dt is acceleration.
Oh, wait, so
Peter?
because the y-axis is frequency,
No.
or is that force?
Yeah, that's force. Yeah, it's capital F. Lowercase f would be frequency. Sarah, you got an idea? So I agree that f divided by m is acceleration. But what are you using as your force? What did you say? I'm sorry. No, I think you're headed down the right path.
You don't know what the force is, so you just solve it.
Okay, we can find the force, right?
Yeah.
Is that a good place to start? That makes sense to me. We know the mass, the velocity, and the radius. Okay, so let's do that. So we get 85 kilograms times our velocity, which is 8.3. Don't forget to square it. Divide it by the radius of 3.5 meters. And that gives us a centripetal force of... What is it? 1,673 newtons? Okay. Thoughts now? Carla?
So, when you have the slope of a graph, it's rise over run. So if you put force over velocity, isn't that the slope?
So that would give you the average slope.
Okay.
The problem is that we are looking for one specific slope, an instantaneous slope, right? So somewhere in here, there's a point where the velocity is 8.3. There's a corresponding force. We want this slope, right? Do you guys see that? So this red line, that's what we're looking for, is the slope of that line. M for slope, not M for mass. Brendan?
Yeah.
How?
I got 9.
You can do like what we're doing in math right now.
Related
Oh, wait a minute. So what you're telling me is, so the slope of this is the derivative of force with respect to velocity, right? And you're telling me that that's an equation for, thank you,
Whatever's constant.
force as a function of velocity, right?
Trying to find is the variable. Please don't. No, change it.
I know somebody who likes gummy bears a whole lot.
Was it you?
It was me. It still is.
We left.
All right, so yeah. So Brendan's thought here is perfect. I don't actually know if we need I don't know if we need this force. Now I'm talking with a gummy bear in my mouth. I don't know if we need this force. Brendan's exactly right. Look, we're looking for the slope of a force-velocity function. So we're looking for the derivative of force with respect to velocity, right? Oh, here's an equation that expresses force in terms of velocity, right? So take the derivative of that function. Right? Might be easier to write it this way. So that means the derivative of force with respect to velocity is, well, m and r are constant, so bring the 2 down out front, so you get 2m over r times v, right? Does that make sense? Oh, and then just plug in your numbers. So the derivative of force with respect to velocity, when velocity is, what is it, 8.3? Ah, this seems like it might actually have some merit. So let's say 2 times our mass was what, 85 kilograms? Our radius was 3.5 meters, and our velocity is 8.3 meters a second. So whatever that gives you is the answer. Okay? Yes?
Okay, when I did it with the first equation, and then I divided.
When you say the first equation, you mean this guy?
No, the thing on the top of it.
This guy?
Yeah, and then I divided it by 2 and 8.3, and I got the answer.
Oh, I gotcha. Let me see if I can explain to you why that works. It's not obvious that that works. So the dividing by 2 is taking an average. So what you did is you found the average slope between here and here. Oh, wait a minute. That doesn't even work, does it? Because dividing it by 2. You divided it by 2?
I got
I hate it too.
Huh.
Oh yeah, I got like double for both ones here. Or half the answer.
Right. I agree that works. I think that figuring out why it works, Sarah, would take some work. Yeah, I don't think that's at all obvious why that works. In fact, so you did your force divided by your velocity, so that's this slope. But dividing it by 2 would make your slope less, not bigger. I don't know, can I think about that and get back to you? Is that all right? Okay, yeah.
On the AP test, for a question like this, would it be all right if you used the definition of the derivative and took the limit?
Like the limit as v goes to 0? Absolutely.
Shows a point.
All right, let me write myself a note to look at 7a again. Okay, everybody good with this? All right, so this is, I mean, I agree this was sort of out of the blue because we haven't done any derivatives problems. I'm going to start putting them in a little bit more often, particularly the next unit on work and energy is going to have more derivatives, okay? And the occasional simple integral, okay? So you guys are going to have to start getting used to those, all right? As a quick comment, and then I'll get your question, Carla. If it's asking you for a slope, that's a good guess that you need to take a derivative. All right? The only time you can just flat out find slope is if your function has a constant slope, and this one does not. Okay? Now, how did we know we had to integrate this with respect to velocity? Well, remember, what you integrate with respect to is always what's on your x-axis. Do you know what I mean? What did I say?
Yeah, you're saying integrate.
Oh, am I saying integrate? I'm sorry, differentiate. My bad. So yeah, so how did we know we had to differentiate with respect to velocity? Because that's what's on the x-axis. Okay? All right, so that's number 7a. 7b, where did I put my sheet? 7b, what's the angle? No, that's the wrong problem. 7b, here we go. Graph B is a plot of f for a range of possible values of t, the period of the motion. What's the slope? So same idea. So for 7b, you've got a graph that looks like this. Here's the force required to maintain period t. So again, we're trying to find the slope of the function when the period is 2.5 seconds. So it's the same process with one extra step. So last time I took the derivative of this function with respect to velocity, right?
Yes.
So what am I going to have to do here?
You have to get velocity, or t in terms of velocity, period in terms of velocity.
Yeah, we need to find a way to put t, period, into this function, right? So, I know, because I took honors physics last year, that velocity is 2 pi r over period. And I think I taught you that when we started this section, so it wasn't just from honors last year. All right, so substitute that in up here. So you got centripetal force is m over r times v squared. Follow? So this is going to give you, what, 4 pi squared r over t squared, right? Which I would probably rewrite as 4 pi squared r t to the negative 2.
You lost?
Oh, I lost my m, sorry. Thank you. All right, and then just take the derivative of that and plug in your period. Cool, you guys? Questions, issues, concerns, anything? That was number 7. What's the moral of the story in like a couple sentences or a couple words?
Derivative.
Take a derivative if you're looking for slope. Cool?
Yeah.
Oh, Carl, you had a question 7 hours ago. What's up?
Well, I was just wondering, so I did rise over run because I didn't think about the derivative, and I got exactly half the answer twice.
That was what Sarah's question was too.
Oh, sorry.
Because wait, no, that's okay, that's okay. So what you're doing there is you're finding the. Oh, you got half of the answer.
Yeah,
So you had to double your answer.
yes, I doubled.
Okay,
it.
then I'm
That's
back
why I
on
did
board.
the answer.
Right? Is that right, Sarah?
Is it 1 over b minus a? Is that why?
1 over.
Like, is it like the average value
Oh,
of it?
Yes,
Yeah.
it's the
Okay.
average slope. Yeah.
Cool. It's kind of weird, but kind of cool.
I think you doubled your answer, Sarah, instead of dividing it by 2.
Yeah, I got.
Will you double check? Maybe not right this second, or maybe.
I got 200.
You have 2 minutes after class.
Yeah.
Let's talk after class.
All right.
All right. So, are we good? All right. Cool. Let's move on to number 8.